In this experiment, we will be doing the water level controller, and what is the performance of doing water level controller with different controllers like on-off controller, P controller, proportional controller, PI controller, PD controller, and PID controllers. So first I will explain with the help of a block diagram which is given in the plan, and then I will show the different components in the plant, and then I will come to the different controllers. So this is the block diagram. This is the block diagram which will help us to understand the setup, and this is the main system that we need to control. So this is the process tank, and the objective is we need to make the level of water in the tank at a particular constant value. So the problem is that if this tank doesn't have an outlet, we know that if we put some water, it will maintain the level. If there is no disturbance, it will be maintained at that particular level. But the issue is that this process tank has an output. So there is some water which is always going out of this water tank, and because of that, this level will not stay at a constant value, but rather it will keep on reducing. Okay, so that is the peculiarity of this tank. This tank will have a constant output, and the control objective is we need to maintain the level of water at a constant level. Okay, so for that what we have is we have a reservoir tank which contains a certain quantity of water, and what we will do is we will take water from the reservoir tank and we will fill in the process tank so that we can maintain it at a constant level. So in order to help us to take the water from the reservoir tank to the process tank, we have a pump here. So the pump will enable the water from the reservoir tank to the process tank, and we don't want the water to be taken without any control from the reservoir tank to the process tank, but we need the water to be taken in a controlled fashion. Okay, so for that we have a control valve here. So these are the main components: the process tank, where we need to maintain the level of water. The water is stored in a reservoir tank, and in order to maintain the level of water in the process tank constant, we have a pump which will take the water from the reservoir tank, and there is a control valve here which will control the quantity of water which is taken from the reservoir tank to the process tank. Now you might have studied in your control system that in order to make sure that the control objective is obtained, or in this particular case, in order to make sure that the water level is maintained at a particular height, it is required to measure, or we need to take the feedback. So in order to take the feedback, we need to measure the current level of water in the water tank using some particular transducer or sensor. Here we are using a capacitive transducer to measure the current level of water in the water tank, and that is being taken as feedback, and we can specify the set point. So here SP is denoting the set point. What is the level of water that we need to maintain in the process tank? So the set point is compared with the feedback, and it is given into a controller. So this controller here, in this case, it is the computer is acting as the controller, and in that controller we can use different control algorithms. Like some of the basic control algorithms are: one is on-off control. So on-off control means you need to switch on the valve when the water level is below the set point, and you need to switch off if it goes above the particular level. Similarly, there are other controllers which we need to set in the computer, so that I will show it later. So this control action need to be given to this control valve. So remember, this control action is taken by the computer, and it is through a digital data acquisition system. It is taken as a electrical signal, but here we know that in valve we need some pressure signal. So we require a current to pressure converter here. So this is actually a current to pressure converter, which actually changes the current signal that is coming from the controller to the pressure signal. So in order to provide the required pressure, we have a compressor here which will have the required pressure, and that compressor pressure will be given to the control valve so that it can be in a suitable position so that the controlled amount of water will come into the process tank so that we can maintain the level at a constant value. So this is the block diagram. Now I will show the different components in the experiment. So this is the process tank that we are talking about. So here you can see there is a scale here by which we can measure the height of water in the tank. And so this is the tank where we need to maintain the water at a constant level. So as I mentioned, the peculiarity is that it has an output port here. So always the water will go out, and we can actually fix it. So we'll fix the output quantity of water at a particular level here. And so this is the reservoir tank that we have seen, where the water will be taken from this reservoir tank to the process tank. And so this is the current to pressure converter that we have talked about, and this is actually the valve mechanism. So inside this, so there is a valve mechanism. So while doing the experiment, you can see that this valve will move up and down to get the proper control action. And behind this you have the motor. So this is the pump which takes the water from the reservoir tank to the process tank. So these are the main components. Now I will show in computer how we can do the control selection. So this is the program to perform this water level control. So we need to select which is the control system. So here we are selecting a level control, and in control you can see there are different options. There is on-off control option, there is proportional controller, PI controller, PD controller, and PID controller. So depending upon the controller that you are choosing, there are different settings are available. So I'll show you some of the control settings. If it is on-off control, so I have selected the on-off control. So in the settings, the parameters are, the different parameters for on-off control is, you need to set the set point. So set point is the level where you need to maintain the level of water. So you can fix it at say 15 centimeter. And another quantity that you need to specify in on-off control is differential gap. So if you see this particular graph, so this is the set point. So I have kept the differential gap as 10. So I'll accept it and I'll show what is differential gap. So you can see that here there is a blue line which is the set point, and the differential gap is actually this the difference between these two pink lines. Okay, so this is actually 10. So what it says is that on-off control will be active between these two regions. That means if the water level goes above this 20, the valve will close and the water level start to decrease. So water level will keep on decreasing, and once it reaches below 10, the valve will open and the water level will increase. So that is actually on-off control. So where it need to on the valve and off the valve is mentioned by this differential gap, and this is the average level that we need to maintain in on-off control. So that is the setting of on-off control. Similarly, for other control parameters we have different settings. So if I am selecting proportional controller, then if you check the parameters, the settings are you need to specify set point, and for proportional controller you need to define the proportional gain, which is denoted by Kc. Similarly, for other controllers, for example, I will take one more controller, PID controller. So for PID controller you need to set the parameter set point, and the PID gains, Kc is denoting the proportional gain, Ki is denoting the integral gain, and Kd is denoting the derivative gain. So we need to select which is the controller that we are selecting, and we can start and do the experiment. So we will demonstrate some of the performance of some of the controllers. So we are selecting the level control. Now controller we are selecting is on off controller, and we are starting. Okay, so we have done the on-off controller. Now we will do the proportional controller. So I am selecting the proportional controller here, and I need to set the parameters. So I am setting the set point as 15. You can set the controller gain, so I am setting the control gain as 2. Now I'll start the process. So now we will do a proportional integral controller, PI controller. So I am selecting PI controller, and we need to set the parameters of PI controller. So the parameters are, we need to define the set point, so we'll keep the set point as 15 itself. And in PI controller we need to define the proportional gain Kc and integral gain Ki. So we'll keep it at the default values, but it can be varied, and you can see the differences as well. So I'm accepting that. Now I'll start it. Okay, so we have done three controllers: on-off controller, P controller, and PI controller. Similarly, you can do PID controller as well. So in this graph, this yellow line is denoting the level of water in the process tank, and this red, the pink line is denoting the position of the valve. So if you have observed in on-off controller, this this valve will be either in the on position or in the off position, while in proportional P controller and PI controller it will be proportional to the error, and in PI controller it will be having proportional plus integral to the error signal. And if you notice, the difference between these controllers is that in on-off controller, if you have seen, the level of water will not be maintained always at the fixed value. We have set the set point at 15, but it will switch between the differential gap. So it will be in this manner. So it will switch between the upper limit and the lower limit. So that is the problem with on-off controller. In the case of proportional controller, we will have a steady value, but there will be always a steady state error. In the case of proportional controller, it will not settle at the set point that we have fixed, but it will have a steady state error. But in the case of PI controller, since we have using PI controller, the steady state error will be 0, and you can see that the level of water is settling to the settling point.